Hi, welcome to my shed. My name is Paul Hopewell. Firstly, I'd like to say thank you to all my subscribers. I also want to say to those who've seen my videos for the first time, please subscribe and click the bell to get the latest updates and releases. Today's video is about another experimental project that I've been toying with. A while ago I made a Eureka relieving tool big enough to work on larger cutters. But after seeing a YouTube video by a guy from New Zealand called Jeffrey Croker, I decided to take up his challenge. His challenge was, is there an easier way to make gears on a shaper? This is a prototype that's going to use a method that I've seen many times on YouTube. This one will have a few changes and I think it'll help. I'm going to leave this device open for anyone to copy or modify. The requirements are that the device must be able to cut between 10 and 100 teeth on any PCD using minimum tools, and it must be fully adjustable and easy to set up. All but one I've seen on YouTube employ a strong wire supported by a fixed point at each end. It's wound over a set PCD roller that in turn manipulates a gear blank under a cutter, producing a gear tooth shape. My idea is to use a solid bar as a push-pull link to rotate the gear blank about its axis. This bar is to be connected to one fixed point on the shaper, the other end connected to an adjustable PCD index arm, indirectly connected to the gear blank rotation shaft via an index plate. Unlike an indexing head or table, each hole represents a gear tooth, not a division of rotation. Because the number of or the sequence of holes represent a gear tooth, I've deduced that I need 50 sets of holes ranging from 51 to 100 holes, and I'll explain more later. The arm, a device that manipulates the gear blank under the cutter, is clamped to the indexing plate via a clasp or a clamp that works a bit like a disc caliper on the car's braking system. It should easily allow the index plate to be freed, indexed and then reclamped. What I'm drawing on the whiteboard is a side view of the index plate and the arm mechanism. These rough sketches are my way of working things out, and they've always been proven to be most successful. Why do I need so many index holes, I hear you ask? An index table uses a set of registrations that is a series of revolutions and added index holes to advance to the next position. This isn't the case with the direct indexing system, so in order to produce 100 teeth on a gear blank, I would need 100 index positions. The thing is, 100 holes will also cut 50, it'll cut 25, 20 and 10 holes. And a 51 tooth gear registration will cut, well, 51 and 17. There are some numbers in the system that will only cut that number, like say 71, prime numbers. Therefore the combination of 51 up to 100 indexing holes will enable the full sequence of 10 to 100 teeth to be formed. In order to make sure that such a large number of holes can indeed be cut onto a 6-inch blank, I used a CAD package to help me devise a hole pattern to fit on as fewer plates as possible. Yes, I've been delving into junk piles again, and this lot is going to have to do. I did have to buy 7 6-inch diameters by 6mm plates though. I suppose that means I've got to go back to eating baked beans for a week or two, I suppose. Here's a tip. To mark out on black plate, try this little trick. Grind some chalk stick to a fine powder, then add a little methylated spirits, just enough to turn it to a paste. Then brush it onto the black plate and let it dry. It doesn't take long. Then you can mark out and quite clearly see where you've marked. Here I'm marking out the centre hole and marking out for the 40mm 3-hole PCD. This bit of the operation is a bit iffy, but to hold this plate I had to use the 4-jaw chuck. Even so, each jaw is on its limit whilst clamping this plate. Each stage of the drilling process takes the bore out to 20mm, and from then on I have to use a boring bar to make the hole 25mm diameter. This is where I drill the 3 holes on the 40mm PCD. I also recess one side of the 3 holes to accommodate the countersunk screws. To hold the plate true on the index table, I'm making an adapter to hold the index plate while I drill all the index holes. There's nothing too spectacular about this adapter except that both sides must be parallel to one another. It'll have 2 spigots on it, one to neatly and snugly fit into the index table, and the other must be a nice firm fit into the index plate at 25mm. On a 40mm PCD it also needs the 3 holes to coincide with the index plate. It needs a hole through the centre to accommodate the 16mm cap head screw, which has been pre-machined to fit into the back of the index table, allowing me to tighten everything together without interfering with any other work surfaces. This bush will have the job of holding the index plate while it's being drilled, and once set and tightened it must never be undone until all of the index holes have been drilled, as setting it up again will be quite a complicated process. The 3 holes will allow me to exchange the index plates as and when I require them. I have toyed with the idea of offsetting the index holes to these screws to reduce the amount of index holes I have to drill. Like having a 50 hole set offset by 50% would give me 100 holes. Then by offsetting the 50 set hole plate again would still give me the 100, 50, 25, 20 and 10 holes that I need. Even so, I would still have to make sure that I had the 10 prime numbers. So I decided to stick with the 50 sets of index holes to make it easy for me. I've still got to drill approximately 3,500 holes to complete the index plates. It sort of makes me wish I'd got a CNC milling machine. Before I can drill the holes, I need something to drill the holes with, namely something to index the holes on the plates, and for that I've got 2 devices, a 40:1 Kearney and Trecker dividing head and a 90:1 dividing table. I've got to sit down to explain this next bit. I used the Black Book reference section on dividing tables and decided to use the 90:1 dividing table to help me drill the index holes. Now I've got the full complement of indexing plates that came with this 90:1 indexing table, and to use them to the fullest I still have 25 sets of holes I still cannot do. However, 8 of those 25 holes can be done on the 40:1 dividing head, leaving me with 17 sets of holes short. That means in order for me to drill the full complement of holes that I require for my index plates, I've got to make some index plates for the dividing table. So I've decided to make the entire set of index plates for the 90:1 dividing table using whatever method I can. Starting with the plates for these, I used a bit of scrap metal and I filled the holes with a bit of weld. I already know I can cut 8 of the 25 holes using the 40:1 dividing head, but the other 17 holes involve me having to use the computer and the CAD program again. and with a little bit of luck and sticky tape I managed to the remaining 17. Yes, I literally meant sticky tape and luck. Calculating the amount of holes I needed for these index plates that fit on the dividing table, I got the CAD program to print these sets of radially lined marking points. I use the lines and not dots because when I go to drill the holes I will mark the paper with the drill and then back off to check the mark against each line as I do them. This method is not as good as having the index table to accurately position the holes, but it is better than no method at all, well, at least in my eyes. This system may be one step up from guesswork, but it is working. All the holes I've cut so far are to give me the full range of holes for cutting the holes in the gear index plates. So here we are cutting the first set of 100 holes using the 90:1 indexing table. I'm not going to do the full 3,500 holes in one go. I'm only cutting the 100 and the 51 set separated by 6 separate lanes representing 6 more sets of holes. This is the main shaft being roughed out to 1 inch diameter. When it's done it'll have a collar welded to it, and the collar will have 3 holes at 40 PCD tapped at M6. I won't show it being welded on or after it's been welded because I think I've told you in the past that I'm not a welder and my welds look awful. After making the collar, then drilling it and welding it to the shaft, I put it back into the lathe and tidied everything up by machining 0.4 of a mil off down to 25mm. I'm going to put a thread on the end of this using my thread cutter, and because I'm using a 2mm thread I need to put a good thread relief on the back so as not to break the tip. With all threads I started with the scratch, cut and checked it, then proceeded to complete the thread. Prototype cutter still cuts a nice thread. The other end of this indexing shaft I'm putting 2 spigots, one at 20mm, the other at 14mm. Then after cleaning all the dimensions up I've used a couple of my lathe change gears to test the fit. There, that's good enough. I'm drilling the end of the index shaft to take an 8mm thread, and then I'll relieve the end 10mm out to 8.5mm. This will take an 8mm by 50mm long cap head screw. This 8mm screw is going to be used to retain the gear blank, so that the screw needs to be a good quality one. I only showed you 2 slots being cut, but I actually put 4 slots on altogether. On the 20mm diameter I put a 6 and a 5mm wide keyway, and on the 14mm dimension I put a 4 and a 5mm wide keyway on. After all, I need it to be as universal as possible. This is where I make a collection of sleeves and bushes that go together to provide packing and support for the gear blank. There's also a couple of items that go to hold the indexing arm in place. This will be the knurled hand locking nut that holds and supports the index arm. I used a side-loading knurling tool to put a grippable surface on the outside edge of this nip knot. I don't like using side-loading knurling tools, so I only used enough surface pressure for a short time to rough the outside edge, enabling me to hand tighten it. This little bracket is the clamp that provides the movement-free indexing, transferring motion from the index arm through to the index plate. With almost all of the sleeves and bushes completed, I've now started work on the main body. This is the upright post that will carry the indexing shaft when it's finished. But before I weld it to the main base plate, I'm going to rough drill and prep it for welding. The base plate is being slotted so that it can be bolted to the shaper. After prepping for welding, I used magnets to keep everything square and used large fillet welds to make it as secure as I possibly could. I put a little bit of black paint on just to hide the mess. Back to the milling machine. I'm going to square up both ends of this main body using one side as a datum edge. Before I clamp it to the angle plate, I briefly ran it on the belt sander to remove any blemishes. Having done that, I could then clean up the front face square to the side face. At this stage, the front slotted face is true and square to one side only. It is square, but it's not true to the bottom face, and at this moment it doesn't matter. So long as I can skim the back face as true to the datum face as I can, that's enough. Cleaning up this back face prepares everything for the next operation. Putting the back face flat on the machine table and the bottom face square up against the angle plate, I can now clean up a small area on the thrust face to give spacers and packers a face that won't distort them out of position. Mounting the back face on parallels in a milling vise allows me to finish the 25mm bore using the adjustable boring bar. This is a snapshot from my CAD program showing the elaborate index arm. I'd originally planned to machine the component out of one solid piece, but as I couldn't find one solid piece, I had to make do with welding two pieces together after machining each part first. The top piece is the part that allows the PCR to be set. The bottom piece is the indexing and clamping component of the arm. We'll start with the PCR segment first. After marking out the PCR segment, it was back to the milling machine to set the centre hole and to cut the slot. I used a 6mm 4-flute cutter to make the slot, which is approximately 104.5mm long. Off camera, I also centre drilled the 20mm diameter relief that will have to be hand filed later. With making these two pieces, I will have to do a lot of hacksawing because my bandsaw is a horizontal gravity-fed type powered saw and hasn't the capacity to allow any freehand working. This is what the PCR section looked like before it was hand filed. And this is the PCR section complete and prepared, ready for welding. Now it's the turn for the index section to have the same treatment, and as if by magic, here is the complete unit sporting the same 20mm hole as the PCR section. Before I welded the two parts together, I used a bit of 20mm bar to align both of these two parts together. After welding the two parts together, I clean up the messy bits, and I mounted the whole index arm in the milling machine to use the same boring bar to bore the hole through to 25mm, so that it slid onto the shaft because it needs to rotate and not grip. Like I say, I'm not proud of the welding, but it'll do its job. Originally it was my plan to use a thin bit of metal to act as a sector arm. After a lot of messing about, it proved to be a bit too flimsy, so after delving into my box of brass bits and bobs, I sourced a bit of bar that would make a brass sector arm quite nicely. Now I have enough components, and I am at the stage where I can at least attempt to make one 50-tooth gear like the one you see in the picture. If you look at the index arm, you'll notice there is a nut and bolt in the slot. In the centre of the nut and the bolt there's a very small indent. This very small punch mark plays a very important part in setting the PCR. A corresponding punch mark exists in the end of the indexing shaft. I'll explain its function in a moment, but first I'll assemble the device. The indexing spindle fits into the main body through from the back face. The indexing plate is then fitted over the 25mm threaded end and butts up to the receiving face on the spindle flange. The three screws can be fitted and nipped up. Next, the index arm is placed over the same end and is pushed up to the index plate. The 25mm threaded thumb nut is fitted and is just hand tightened. The locking clamp is the next thing to be fitted, and for the moment is held in place by one 6mm hexagon screw. Turning the unit round, all that is required now are a series of collars or packing bushes, amongst which one will be the gear blank, before finally having the retaining sleeve fitted and held in by one 8mm high tensile steel screw. This is a shot of the locking clamp and the ground 4mm dowel that will assist the indexing. You'll notice that the sector arm is already set to 2 spaces. Here we are with the device bolted to the shaper at last. The device is also fitted with a gear blank of 77.9mm diameter. In the background you'll notice there's a large section of angle iron. It's attached to the shaper's main body. Temporarily, I know, but it will change to something that's a bit more usable. Between it and the indexing arm is the link rod. Earlier I mentioned a punch mark in the middle of the bolt that is attached to the slot on the indexing arm. I also mentioned about the punch mark in the middle of the indexing shaft. An important part of making a gear is knowing the PCD, the pitch circle diameter. Divide that by 2 and the result is the PCR, that's the pitch circle radius. Using a pair of dividers to set the PCR, I can set the slider screw to the correct position with the dividers and lock it off with the lock nut. You will note that the punch mark on both components are at the same level to help reduce any cumulative errors. Turning my attention to the cutter, it's difficult looking at a gear to determine what the pressure angle is. The tool you see now is set to 14.5 degree PA, pressure angle, and this was pure guesswork, to be honest, and the flat at the bottom of the tool is 1.6 millimeters wide. It roughly fits inside one of the teeth on my 50-tooth gear. To be honest, the gear was made in China, so for all I know somebody could have sat there at a bench and filed it to shape. Who knows? After I had cut the first few teeth, I compared my gear with the teeth on the blank, and it didn't quite match. I then ground another cutter to 20 degrees pressure angle and calculated that the flat on the bottom of the cutter needed to be 1.09 millimeters wide. From then on, the gear looked much better. In the past, I've never really had anything to do with making gears. For me, this is my first foray into making them, and it's a bit of a steep learning curve. I can thoroughly recommend that before you even venture into making your own gears, that your studies include visiting your YouTube sites from Mr. Pete 222 and This Old Tony, then getting yourself a book on making gears. I can guarantee that you will find what you're looking for, but you will need to work out for yourself how to deal with the many aspects of making gears. My way of dealing with the peculiarities of gear making was to make a spreadsheet that calculated and manipulated the information at hand to formulate the important calculations. At the moment, if I input the outside dimension, or the PCD, the pressure angle, and the number of teeth, the spreadsheet spits out the corrected PCD, the outside dimension. It repeats the number of teeth, the tooth thickness, the depth of tooth, the width of the cutting point on the tool, the mod, the diametral pitch, and the root dimensions. Pretty impressive, eh? Well, I think so. Didn't all go swimmingly either. On my first gear, the tool moved in the tool holder, ruining the blank, and I had the wrong pressure angle set. Also, the link rod will need some better bushes made to greatly reduce the amount of backlash within it. Now all I've got to do is drill the remaining 3,500 holes to complete the remaining index plates. That's going to be mind-numbingly fun. That said, my first complete gear was a total success. I hope you enjoyed the video. Thank you for watching. Bye for now.